taken in parallel. So this allows us to generate this transaction. Also running a mirror node, which I like the term hash cache. I thought I'd invented it, but it doesn't like that. We need something that is up to things, up to the requirements technologically.
Whether the current IoT platform, AI algorithm, do you still remember? So it will store the MAC address.
All right. Today, in this demo, I'm going to show you how you actually use Hedera Hashgraph to do the authentication for your IoT devices. So here we have 3 Raspberry Pis, Raspberry Pi A and Raspberry B and M. And this is the architecture. So we assume Raspberry B is already registered in your home network, and Raspberry A, you want to register it into your home network and to control your Raspberry B. And my MacBook is playing the role as edge device here. And they're going to talk to Hashgraph, Hedera Hashgraph, the testnet. So basically the scenario is Raspberry A want to control the Raspberry B. For example, this one is a smart locker, and this one can be a button or your smartphone, whatever it is. And Raspberry Pi M is a malicious Raspberry Pi, so I will use it later. So the idea is very simple, like I already explained. Device A will be registered into a home network through edge device, which is running as in my MacBook, and device B is already registered in your home network as a trusted device already. So device A, you need to register the first time, and they're going to talk to Hedera Hashgraph to do authentication and also store the hashed unique identifier, which is the combination of the file number and the MAC address of your devices into Hedera Hashgraph. So let's get started. All right, the first thing we're going to do is change the file number from whatever number it is to 0, so that when we run the server, we'll create a new file in Hedera Hashgraph. So that's the place we're going to store all our stuff. Okay, so let's do the edit file. So as you can see, that the file number now is 24544, and we're going to change it to 0. Save it, and we're going to run the server. It will actually generate a new file number. Okay, the new file number is created, so we copy here, and we go back to that environment file and put the file number in here. So currently it's all manual, but of course this is something we're going to automate for the end user in the future. Alright, so we run the server again. If everything goes well, you will see the message that you can call the API right now. Alright, it works. So the server is up and running. The second thing we're going to do is to start our device B, which is the smart locker. So I'm already in here, so I'm going to run code client 2. Okay, so client 2 is up and running and listening to the message. So device A and device B, they're actually talking using MQTT for demo purpose. All the devices are running in the same network, but you can actually, I mean, in the real life cases, device A should be, probably running in the internet outside of your home network for example, like a phone using 4G to connect it to your home. So now here we run client 1. You see the private key and public key is generated in your server just for for reading or debugging purpose. You can look at it. So you create a new account number. This is a new account number. Okay, so actually get the MAC address of device A, and then combined with the account number. It's very fast. It's very fast, but it's actually a slowed down version. So let me explain it step by step because it's happened too fast. But so what happened in device A, right? So here it actually registered a new device in Hedera Hashgraph. So there's a function triggered to register this device using its MAC address, and it created a new account number. It's 28018, right? So, and then it tries to talk to device B, and device B is always listening. So the first thing device B sees a message or the connection request from device A, it will do a local check. So there's in the local storage, we'll be storing all these device information, the MAC address and combined unique ID. And if it is already there, then device B can trust the device because it's in the local network. If it's not, then device B need to check if it's already if it's registered itself in Hedera Hashgraph. And if it is, and then we'll add it to the list in the local storage, which is a safe place. So obviously device A, in this case, is a new device. It's not in the local storage. So device B asks this device to be authenticated. So we'll call the function, do authentication, to call the API, a Java API to Hedera Hashgraph to check. So start authentication, and it found actually the MAC address, this MAC address to be checked. And the account ID is 28018, right? So this is the server and some parameters, and there's also states, meaning true means the authentication is successful, and the client is authenticated then. So now the client can just send its MAC address followed by a semicolon and then its message. So basically it can send a message, and the message device A sent is hello future. Quite simple, right? So if you look at the server side, it generates the private key and public key, and this is just for display purpose, right? So a new account is created, and it's appended the ID, which is this 28018. This is the account number, and together with the data, this is a hashed, basically information of the MAC address. So the hashed text is sent and stored on Hedera Hashgraph. So in our file, right? So meaning that we actually store the MAC address plus this account number, but hashed in Hedera Hashgraph on a public ledger. Everybody can see it, but nobody knows what it is. So by doing that, we are using the power of Hedera Hashgraph, all the nodes, to help you authenticate, to verify your device and make sure that nobody can tamper it later on. So then we can forget or get rid of these complicated keys, username and passwords, and manage certificates if you want to use certificates. Basically make your life easier and more secure. Okay, so now what I'm going to do is to run device A again, basically the same function, and see what device B actually display. So we'll create a new account. You see, this is a new account number, device A, and trying to do the same thing. And you can see here, it doesn't ask device A actually to be authenticated again from Hedera Hashgraph, because it already checked the local storage. It sees that this device is already there, so client is already authenticated, and device A can start to send whatever message it wants. Right, so what I'm going to do now is to pull out our malicious Raspberry Pi device M, and we will run the Python file here, malicious, and let's see what device B will display. Same, ask for this device to be authenticated, and then authentication status is false. So it says device is not authenticated because the MAC address is wrong. So we have never registered this device M into Hedera, so it will never be authenticated. Which means, other people, they can also register any device on Hedera because it's a public ledger, but they will never be able to register their device in your Hedera file because you are the one has the private key that can control the access to it, right? And you can see here, in the server you can see the text is hashed, but nothing stored in anywhere, because this device is not belong to us, not belong to me. It's a malicious device from some bad guys. Okay, so by doing this, you actually make device A to be recognized in your home network, and then they can talk freely to each other. Device A can talk to device B, and your home networks is always secure, because anything that want to enter your home network, they need to be registered by you on Hedera Hashgraph. And we use the power of all the nodes there to verify any IoT devices for you.